Okay, in this video I'm going to talk about the multinomial distribution. I'm not going to go into any great detail about why the formula is what it is. I'm just going to show you what it is, how to use it, and how to use R to get a probability. Okay, so like what kind of situation could we be talking about here? Let's imagine that your mood when you wake up on a given day is a random variable. And suppose that there's independence from day to day. Of course, we know that this isn't necessarily the case, but just humor me and let's pretend that this has some kind of correspondence with reality. Let's say that there's a 0.5 probability that you wake up happy, and there's a 0.2 probability that you wake up sad, and there's a 0.3 probability that you wake up feeling neutral. Okay, now you're going to do a little experiment where you're going to monitor your mood for 5 days. Well, what the multinomial distribution allows you to do is to ascertain the probabilities of different combinations of these outcomes. So, as an example, what is the probability of being happy on 4 of the days, and neutral on 1 of the days, and sad on none of the days? Okay, so you would write the probability of 4, 0, 1 is equal to the number in the numerator is just your total number of trials, so that would be 5 factorial over the count for n1 factorial times the count for n2, which was 0 factorial. I didn't bother to write it in, but maybe I should have, which we know is just 1 anyway, so it doesn't affect the computation, but times the number of counts for the third possible outcome of each day, factorial. And then what you do is you just get in there and you take the probability and you raise it to the number of counts. So 0.5 was our probability of being happy. We raise it to the 4th power. We multiply that times 0.3, our probability of being neutral, to the 1. The probability of being sad, 0.2 to the 0, which we know is just a 1 and it goes away. So we end up with 5 times 0.5 to the 4th times 0.3, which comes out to about 0.9, it's like 0.093 or 9%. Okay, and in order to do this in R, so I already sort of blew it, so I already have it open, but basically you use D multinomial, so that's the density of your multinomial distribution at the point that you put in. And then you load in 2 vectors. One, your vector of counts, and secondly, your vector of probabilities. You press enter, and it gives you the answer. So let's say what would be the least likely outcome? Well, sad was the least probable. So what would have happened if we had said that we were going to be sad all 5 days? Oops. We get something very, very remote, something like 0.03%. Okay. And by the same token, we should see that that's strange. Probability of being happy every day would actually be less than the probability of being happy 4 days and neutral 1 day. How could that be? Well, I'll leave that to ponder.